This question comes from Alex, who asks, what would happen if the Earth's core suddenly stopped spinning? The short answer is, a lot of geologists would panic, like, immediately. There would be urgent international meetings, frantic emails, and lots of shouting about unprecedented geodynamic anomalies. Probably also someone insisting that this is a funding opportunity. But of course, that's not the answer you came for. Let's see what would actually happen. First, some basics. The Earth's core is divided into two parts, a solid inner core and a liquid outer core. The outer core is a huge mass of molten iron and nickel that moves around in swirling, churning currents. It's this motion that generates Earth's magnetic field through something called the geodynamo. Without it, we wouldn't have a magnetic field at all. So if the core suddenly stopped spinning, like instantly froze up, that geodynamo would switch off almost immediately. Within years to decades, maybe even faster, our magnetic field would collapse. No magnetic field? That's bad news. Really bad. The Earth's magnetosphere shields us from the solar wind, a constant stream of charged particles blasting out of the sun at millions of kilometers per hour. Without that protection, these particles would slam directly into our atmosphere. You might think, so what? It's just some wind, right? Well, no. The solar wind can strip away atmospheric gases over time. That's what happened to Mars. Once it lost its magnetic field, its atmosphere was slowly blown away into space. On Earth, we wouldn't lose our entire atmosphere overnight. But over millions of years, it would get thinner and thinner, making life a lot harder. And in the short term, we'd get a dramatic increase in radiation at the surface. High-energy particles would bombard our satellites, fry electronics, disrupt communications, and bathe passengers on high-altitude flights in extra radiation. Aurorae would become spectacularly bright and appear much closer to the equator. Beautiful, but also a sign that the shield is down. But wait, losing the magnetic field is only the start of our problems. Stopping the core's spin means stopping the convection currents in the liquid outer core. That's a lot of heat that now has nowhere to go. The Earth's interior heat normally escapes slowly, moving up through the mantle, and eventually out via volcanism and plate tectonics. With the core frozen, heat would start building up. The core is incredibly hot, around 5,000 to 6,000 degrees Celsius. That heat can't just disappear. Without the churning motion distributing it, you'd get new temperature gradients building up at the boundary between the core and the mantle. Over thousands to millions of years, this could lead to more extreme and unpredictable mantle convection. Translation? Supervolcanoes. Everywhere. With no stable heat transfer, plumes of hot material would punch up through the mantle in weird, chaotic ways. The world's volcanic activity would ramp up, potentially triggering mass extinctions and climate changes. Imagine dozens of Yellowstone-scale eruptions going off around the world, filling the skies with ash, blocking sunlight, and lowering global temperatures. And let's not forget about plate tectonics. The movement of the plates depends in part on heat from the core. Shutting off the core's motion might eventually shut down tectonics altogether. That means no mountain building, no recycling of carbon via subduction, and a slow, inevitable accumulation of carbon dioxide in the atmosphere without any way to store it in rocks. So first, we freeze the core, then we overheat the mantle, then we suffocate in our own greenhouse gases. Sounds fun, right? But there's even more. If the core stopped spinning instantly, there'd be another effect. The core has angular momentum. It's a massive rotating sphere of molten metal. Stopping it instantly violates the laws of physics as we know them. But let's say some evil genie snaps their fingers and forces it to stop. That angular momentum would have to go somewhere. Where? Into the mantle and crust. Suddenly transferring that rotational energy could cause massive seismic shocks. The entire planet's crust might crack like an eggshell. Earthquakes unlike anything humanity has ever experienced would ripple around the globe. Entire continents could shift in minutes. Cities would flatten. Tsunamis would devastate coastlines. It would be a very bad day. And even if we assume a more gentle stop, not instant but over, say, a decade, the planet would still experience massive geological stresses. Fault lines would become unstable. Volcanoes would awaken, and earthquakes would increase in frequency and intensity. Meanwhile, the The liquid outer core's halting would mean the inner core might decouple from the rest of the Earth's rotation. It might keep spinning at its own rate for a while, causing frictional heating at the boundary, melting more of the core and driving additional weird convection patterns in the mantle. Basically, the entire geodynamic engine of the planet would go haywire. Oh, and let's not forget life. Human civilization depends on a stable climate, reliable agriculture, and predictable seasons. With no magnetic field, increased radiation would damage crops and make parts of the planet less hospitable. Satellite systems for navigation, communication, and weather prediction would be crippled. The increase in volcanism could trigger a volcanic winter, cutting off food supplies. Earthquakes and tsunamis would destroy coastal infrastructure where most of the world's population lives. In the long run, even if we survive the initial chaos, the loss of the magnetic field would slowly strip away the atmosphere and allow more ultraviolet and cosmic radiation to reach the surface. Genetic damage, cancer rates, and birth defects would soar. Eventually, Earth might start to look a lot more like Mars, cold, dry, and barren. So, to sum up, if the Earth's core suddenly stopped spinning, we'd get loss of the magnetic field, solar radiation bombarding the surface, satellites fried, communications disrupted, atmospheres slowly lost to space, huge seismic and volcanic activity, breakdown of plate tectonics over time, potential mass extinctions, ultimate transformation into a less hospitable, possibly even uninhabitable planet. On the plus side, well, actually, there is no plus side. At least the auroras would look cool for a while, but after that it would be hard to enjoy them from your radioactive volcanic bunker. So, let's all be glad the core isn't going to stop spinning anytime soon. And if it does, I call dibs on being the first one to send a very polite but very urgent email to the International Geophysical Union. They're going to want to know about this.